Hi guys, welcome to Ontogenesys Automation's quick review and quick preparation program. So, inductors. Inductors. What are inductors? Inductors opposes the change in current. If current changes, it opposes the change in current. See, we should recall two basic fundamental laws of materials, that whenever current flows through a conductor, magnetic field produces around it, and whenever the flux linked with a coil changes, then EMF is induced in that. Okay, so this was what, this was your Faraday's law of electromagnetic induction, and this is your basic property, is that it? So now when we apply some voltage across a inductor, so current I flows through this. When the current flows, it produces some magnetic field. If it is AC current, then this magnetic field will vary. That means the flux linked with this coil will vary. Once the flux linked with this coil varies, it induces one EMF, and this EMF sets another current, and this current, direction of this current is opposite to the main current, because it is as per your Lange's law. Remembered Lange's law? What it says, that it opposes the very cause that produces it. Lange's law, it opposes the very cause that produces it. Okay, so we can say that inductors oppose the change in current. Inductors oppose the change in current. V is equal to L d I dt, where L is the unit of L inductance is Henry. L is given by your N phi by I, the flux linked and current flow. Okay, N phi, we will discuss it later on. Okay, we will discuss it later on. So this is L is in Henry. Now what amount of, see, in case of resistance, when current flows, when we apply voltage, current flows through R and I current flows, then it there produces heat I square R. This is the work done. You can say this is the work done or heat release. Now in case of inductor, it stores energy. And energy stored is given by E is equal to half L I square. This much of joule is stored in the inductor. Okay, so now this inductor, in case of your AC, the magnetic field varies, so inductor has its effect, it opposes the current. But in case of your DC, the magnetic field is constant, so it doesn't vary. Thus inductor acts as short circuit. This is important. Inductors act as short circuit in case of your DC current. Okay, now what about your capacitor? Okay, come to your capacitor. Capacitor is nothing but two two charge plates or anything, two charges separated by a gap. Is your capacitor. Okay, suppose in case of our transmission lines, in between these 2 points there is air gap, so these 2 points will behave as a capacitor. Okay, there will be capacitive effect. Now capacitor, two conductors separated by a dielectric medium or air is capacitor. Okay, so I is equal to C dV dt, or you can say this capacitance C is Q by V, charge per voltage. So charge on capacitor Q can be given as C into V, the voltage applied across the capacitor into the capacitance of this capacitor gives the charge on the capacitor. C is equal to epsilon A by D. So see here, the capacitance of capacitor depends on area of the plate, nature of the dielectric medium, whatever we put in between the two plates, it depends on this dielectric medium, area of the plate, and the gap between the plate, this the separation. Okay, but it do not depend on the thickness or volume of the plates, because charges are always present in the surface, not in the core. Okay, so it doesn't depend on the thickness of the plate, it depends on the area of the plate, nature of the dielectric medium, and gap between the two plates. Okay, doesn't and it doesn't allow the change in voltage, capacitor does not allow the change in voltage. Remember, inductor doesn't allow change in current, capacitor doesn't allow change in voltage. So capacitor acts as open circuit in case of your DC. Capacitor acts as open circuit in case of DC. Once we provide DC current, the static charges will develop and this will act as a open circuit. As similarly as your inductor, energy stored in capacitor is given by E is equal to half CV square. This stores energy, and remember the capacitor stores energy as electric field in the form of electric field charge, and inductor stores energy is in the form of magnetic field. Okay, we will have a one more video on your electrostatic and your magnetism. We will understand all those things there. Electrostatic is related to your capacitor and magnetism is your inductor. Okay guys, so one last point is that types of capacitors are pepper type. These are used in your power circuits, in household devices, equipments, etc. Your mica type capacitors. Mica type capacitors are very good, but they are costly, used in high frequency circuits. These are low cost pepper type, and they are used in your power circuits, in your houses, household equipments, etc. Then your electrolyte type capacitors are used in your DC circuits to reduce the ripple in voltage waveform, to reduce the ripples in voltage waveform. Okay, so electrolyte type are used in DC circuits to reduce the ripple. Pepper type are used in our power circuits, and mica types are costly and high frequency uses. Another type is your polyester type. Polyester type are high voltage purpose, are used for high voltage purpose. Remember these four types of capacitors. Okay, so guys, this is I think I have covered most of the important points on your basic electrical, and a few points are left though. Likewise your charge of electron is 1.6 into 10 to the minus 19 coulomb. 1 coulomb charge is equal to 6.242 into 10 to the 18 number of electrons, and positive charge of proton is equal to positive charge of electron. Number of protons is equal to number of electrons. Atomic number is equal to number of protons. Atomic number is given by number of 1 electron volt is equal to 1.6 into 10 to the minus 19 joule. Mass of proton is equal to 1.66 into 10 to the minus 27 kg, and mass of electron is 9.1 into 10 to the minus 31 kg. See, atomic weight or atomic mass is equal to weight of the nucleus, proton plus neutron. This is not that much important. And resistivity, if we compare the resistivity of material, then you can see here, see, silver is your 1.64. Silver has resistivity 1.64, copper 1.72, aluminum 2.8, gold 2.44, carbon 3000 to 7000. These are in ohm meter. Resistivity, unit of resistivity is ohm meter. So carbon 3000 to 7000, and eureka, manganese constant, and I have mentioned many times, they have almost around 40 or 50, 49, 44, 48. Manganese 44 to 48, and eureka and constant 49. So these are the conductors. Okay, and iron 9.8, nichrome heating coil, it has resistivity of 108. Tungsten 52.8. Tungsten is used for valve material and have high melting point, so for 52.8. So these are the resistivity at 20 degrees centigrade. Okay, so guys, this I think I have covered most of the valuable important informations on your basic electricals. If you people have liked my video, then kindly like, don't forget to like our videos, subscribe our channel to get more videos, do comment, do give your feedback, because your feedback is necessary for to make more precise videos, more valuable videos for you people. We can rectify our faults, whatever. If you are having any doubt or any queries, anything, you can contact us. So thank you guys, bye bye. स्पाइरल टाइप का बर्डन ट्यूब होगा. दिस इज द बर्डन ट्यूब. यहाँ पे देखो ये फिक्स्ड है, हम पढ़ते आए हैं कि फिक्स्ड एंड. तो ये हो गया तुम्हारा प्रेशर गॉज.